Hello, students. You are welcome back to class. Our lesson for today is on the topic acids. I'll be defining the term acids. I'll be talking about the different classes of acids. I will also talk about the physical properties and chemical properties of acids. Then we'll talk about how to prepare an acid. And finally, we'll talk about the uses of acids. So let's start with the definition of an acid. Acids have long been associated with the sour taste of some fruits, such as lime and lemon. Their ability to change litmus solution from blue to red is also well known. So basically, substances that can change litmus solution from blue to red is called an acid. But in all of this, let's have a more comprehensive definition of an acid. An acid is a substance which produces hydrogen ions or protons as the only positive ion when dissolved in water. This means that an acid has at least one ionizable hydrogen atom in its molecule. Also note that the characteristic properties of an acid in solution are due to the presence of these ions in the solution. So you take note of this. Next, we'll be talking about the classes of acids. Acids are classified based on their source as well as their strength. So the sources of an acid, that's where an acid is gotten from, is one of the bases for the classification of an acid. And also the amount of hydrogen ions that are present in a solution also defines the classification of an acid. So based on the sources of an acid, acids are classified into organic acid, also known as natural acids. So you take note, they're also known as natural acids. And we also have inorganic acids. These are also called mineral acids. So basically, these are the two classifications of acids based on their source. So for organic acids, they are actually obtained from plants and animals. That means they are gotten or obtained from natural materials or products, or substances. So you take note of that. Inorganic acids, on the other hand, they are obtained from mineral elements. They are obtained from mineral elements or inorganic matter. So basically, these acids are gotten. So we'll be looking at some of the examples of organic acids as well as inorganic acid. For organic acid, we have citric acids. They are found in lemon and lime. We also have malic acids. They are found in apple. We have ethanoic acid, also known as acetic acids. They are found in vinegar. Oxalic acids are found in green plants, on green leaves. Lactic acids, they are found in yogurt or milk. They're actually found in milk. So you take note of this. Inorganic acids, we have hydrofluoric acid, hydrochloric acid, hydrobromic acid, tetraoxosulfuric acid, triazonitrate 5 acid, and a whole lot of others. So you take note. So these are the examples of both organic acids and inorganic acid. And you're expected to know them. You're supposed to know them. So you take note of them, both organic acid as well as inorganic acids. So next we'll be talking about the strength of an acid. Like I said before, the strength of an acid is dependent on the amount of hydrogen ion in an acid solution. So when an acid is dissolved in water, the amount of hydrogen ion will define the strength of the acid. So when the concentration of hydrogen ion is high in an acid, we'll say that acid is actually a strong acid. So basically, based on the strength of an acid, we have two classes of acids again, and they are called strong acids as well as weak acids. So you take note, we have both strong acids as well as weak acid. Take note, the amount of hydrogen ion in an acid solution defines its strength. So based on that, we have both strong and weak acids. So these are the basically two types of acids that we have based on the strength of an acid. So for a strong acids are acid that ionizes completely solution, and you can see the following examples of strong acid. While weak acids, on the other hand, they ionize partially. They ionize partially in solution. So you take note. So examples is what you are seeing there. We have ethanoic acid, we have triazocarbonate 4 acid. So let's talk about the physical properties of an acid now. Dilute acids have sour taste, but you don't need to test an acid. So many times we get this taste from unripe fruits. So that taste you feel when you take unripe fruits, it's an acid. It tells you that that fruit contains acid. Acids also turn blue litmus paper red. And finally, concentrated forms of strong acids are corrosive. An example include concentrated HCl, concentrated tetrasulfate 6 acid. Let's talk about the chemical properties of an acid. Number one, reaction with metals. Acid reacts with some metals like zinc, iron, and magnesium to liberate hydrogen gas, as you can see from the equation. So when acids react with metals, they liberate hydrogen gas. So you take note of that. Reaction with bases. Acid reacts with both soluble bases as well as alkalis to form salts and water. And this reaction is known as neutralization reaction. So you take notes. It's known as neutralization reaction. So finally, we'll talk about reaction with triazocarbonate 4. Acids react with triazocarbonate 4 to liberate carbon 4 oxide, as you can see from the equation. When an acid reacts with triazocarbonate 4, what is produced is salt, water, and carbon 4 oxide. Now let's talk about how acids are prepared. Here's an outline of the general method for preparing acids. Number one is dissolving an acid anhydride in water. Two is by the combination of the constituent elements that make up the acids. So you take note of that. And finally is by displacement of a more volatile acid from its salt. So you just need to know the various ways we can prepare an acid in the lab. So finally, we'll be talking about uses of acids. So we're just talking about few uses of some acids, starting with ethanoic acid. Ethanoic acid is used in preserving food. It is also used in the textile industries, in dyeing silk and other textile materials. So you take note, basically, that's what ethanoic acid is used for. Hydrochloric acid, on the other hand, is used to remove rust. It is also needed in chemical industries to make certain chemicals. So you take note of that. So next we'll be talking about tetrasulfate 6 acid. Tetrasulfate 6 acid is actually used as a drying and a dehydrating agent. It is also used as an electrolyte in lead acid accumulators. An electrolyte is a substance that conducts electricity and it is decomposed in the process. Finally, we'll be talking about fatty acids. Fatty acids, they are used in the manufacture of soap. So examples are palmitic acids as well as stearic acids. So they are used in making soap. Thank you for watching. See you in my next class.